So today we will talk about some numbers and basically it is about natural numbers. Okay, we will see that how natural numbers seem to be more fundamental than the numbers itself. So first of all, it seems strange to me that when we are asked to think about some numbers, we are most likely to think about numerals, and especially Hindu Arabic numerals like these. As you can see here, these are just numerals, these are not numbers. Okay, these are just symbols, and we have assigned some symbols to the numbers. But if someone asks to us that what exactly numbers are, then uh, how should we reply to them? I mean, what is to be said? What are the numbers? Not the symbols, not the numerals, but the numbers. What the numbers are. So, in their most primitive form, the numbers are observed as something which we use to count. So, if say chronologically, one can say that natural numbers are more fundamental than the numbers themselves, as I have said before. Therefore, we can shift our analysis to the natural numbers rather than the wide spectrum of numbers, because this wide spectrum of numbers is something we cannot cover in a single video. So, when we say that we are going to deal with the natural numbers, then yes, it makes the goal somewhat attainable. Okay, so before asking what natural numbers are, let's see what we already know about them. We know that natural numbers are the numbers, again reminding you, not numerals but the numbers 0, 1, 2, 3. Some people exclude 0, and it's well known. We are uh, taught in our junior classes that 0 is not a natural number, but some people include 0, and some do any one of both, which is useful for their problem. So, for our case, in our case, we will assume it to include 0. Similarly, many things like we can use natural numbers as cardinals, ordinals, and nominals. Many things are there we can do with this. But you know what? I'm more interested in defining natural numbers from scratch rather than merely using them. So, an informal way to do is to define a set. As you can see here, our set contains 0, 1, 2, 3, 4, 5, and these numbers, the set of these numbers, I have assigned as n. Okay, n is a set which contains these numbers. So, and we can define natural numbers as something which starts from 0 and then goes on indefinitely without the repetition. Okay, and this these natural numbers which I am saying starts from 0 and then goes on indefinitely, this is n. As you can see that after 5 there are dots, so these dots are showing that we are not stopped at 5, but we are going indefinitely after 5 up to infinity. Okay, so however it seems, but it is not. What? It is not a good definition of natural numbers. Why? There are two reasons why. The first one is the method of circulation which we are using to define natural numbers. Now, what is this method of circulation? We are using an advanced concept, that is the concept of set, to define a fundamental concept, that is the concept of natural numbers. As you can see, when we are asked to define natural numbers, what we did, we used the concept of set, and then with the help of the concept of set we are defining the natural numbers. And since this advanced concept of set itself cannot be defined without using a fundamental concept, so it's a kind of loop. As you can see, what loop is that you are using the concept of set, and then with the help of this set concept you are defining. So we understood that why we can't use the concept of set to define the natural numbers, because it is creating a loop, a circulation. Okay. Yeah, this was the concept of loop, which I have said as method of circulation. Okay, so we can't use this. So what to do now? uh, Another problem is our assumption that the elements of the set n are not repeating themselves, which is absurd, and the definition will said to be established on an absurdity if we define n this way. So let's now do something more concrete, okay, in defining the natural numbers, starting by some operations on natural numbers like this. As you can see, here we have 5 raised to the power 3, means 5 cube, which is nothing but 3 times multiplication of 5 by itself, like this. And again, these multiplications are nothing but the 5 times addition of 5 times added quantity to itself, like something like this. As you can see, 5 cube means 5 multiply 5 multiply 5, and this is equals to the 5 times addition of the 5 times written 5, means the 5 times addition of 5 times added quantity to itself. So we can write like this. Now it means the operation of plus, yeah, I mean, means the operation of addition is more fundamental, which is defined as the incrementation, or simply increment in the natural numbers. But okay, so what we learned that 5 plus 3 means the incrementation of 5 by 3 times. But since we are trying to define the natural numbers from scratch, let's forget about these numbers like 5, 3, 1, and so on. Therefore, as we have a fundamental operation of increment, now we also need a fundamental natural number from which all other natural numbers will pop out. After applying the increment operation, as we have done above earlier, let's represent this fundamental natural number by the symbol 0 and its successor by 0 plus plus, and next successor by 0 plus plus, and again a plus plus. What does this mean? 0 plus plus means that we are applying the operation of addition on the fundamental natural number 0. And what does it mean to write 0 plus plus and again plus plus? It means we are applying the operation of addition on the fundamental 0, then the quantity which will be resulted will again be uh, applied by the addition of operation, and the further successor in the same fashion. Now we can use these two fundamental objects 0 and plus to define the natural numbers completely. and our natural numbers are like this: 0, 0 plus plus, 0 plus plus, plus plus, 0 plus plus, plus plus, plus plus, and 0 plus plus 1 operation, first operation, plus plus second time operation, plus plus third time operation, and plus plus fourth time operation. To remove the burden of writing so much plus, we can assign something shorter and simple to these natural numbers with enormous plus as follows. We can assign 0 plus plus a symbol that is like this. Similarly, a different symbol like this for 0 plus plus and plus plus. Similarly, again another symbol for 0 plus 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 and so on. So finally, our natural numbers are the following objects as you can see. And remember, these are just symbols. We can conclude all this in terms of two axioms, which will define our natural numbers n, not as a set but a representation tool. Okay, this n is not a set, but it is only a representation tool because we don't want to again uh, bother us to, I mean, use the method of circulation here. So this n is for indication only. Okay, so all we have done up to now can be concluded through two axioms. First axiom is that 0 is a natural number, and the second axiom is if n is a natural number, then n plus plus is also a natural number. So in this way, one can define the natural numbers. Okay, thank you.